In the previous video, we looked at the radial distance between the two bodies, and we wrote that as this constant over 1 plus epsilon cosine of theta minus phi, the phase. And we then showed that this can be written from the geometry as 1 minus the semi-major axis times 1 minus the eccentricity squared over 1 plus e cosine theta minus phi. Let's now show this result. And for simplicity, so let's draw an ellipse. Not a good ellipse, but whatever. Let's not worry about that. So here's 2a this way and 2b this way. And the body of mass M1 is there. The body of mass M2 is going on this path, right? It's an ellipse. Here is the R between these two objects. Let's just replace this with some, I don't know, alpha. So more generally, we have R, and sometimes this quantity is called P, so let's simplify that. It's called P, where P is H squared over G M1 plus M2. And therefore, it's P over 1 plus eccentricity times the cosine of alpha. Okay, as alpha varies, that traces out an ellipse. Let's call this point C. Let's call this point here point D. And let's call this the origin, O for origin. So OC, the distance OC, is just P. When alpha is 0, we have cosine of 0 is 1, so it's P over 1 plus the eccentricity. And the distance OD is equal to P, right? The angle alpha is pi in that case. And so we have 1 plus E cosine of pi. That's a minus 1. And so we have P over 1 minus the eccentricity. And of course, OC plus OD is just 2A, right? So that's twice the semi-major axis, which we can write as P over 1 plus epsilon plus P over 1 minus the eccentricity. What's this epsilon? 1 plus the eccentricity, 1 minus the eccentricity. That has to be equal to 2A. And therefore, let's find the common denominator, right? We're doing P times 1 minus E here. Here we have 1 plus E over 1 minus E. And so here we have plus P times 1 plus E, and that's equal to 2A times 1 plus C times 1 minus C, which of course is 1 minus E squared. And so we get a, what am I doing here? Jumped a step. We have, that's equal to 2A. And so we have P minus PE plus P plus PE. So we have 2P over 1 minus E squared equals 2A. And therefore, P is equal to A times 1 minus E squared, as we claimed.